Hi students, today we can see structures of IIR filters. So IIR filter, a filter designed by considering infinite samples of impulse response is called infinite impulse response filter. IIR filters are recursive as the current output y of n depends on the past output, present and past inputs. That is y of n is equal to summation minus summation k equal to 1 to n k equal to 0 to m b suffix k x of n minus k. So the output y of n depends upon the past output, present k equal to 0. So present and past inputs here. So I can expand this equation, the summation, as substituting your k value as 1 to n for y of n minus k and k is 0 to m for x of n minus k. Now taking the z transformation, so y of z and y of n minus 1 as z inverse y of z, y of n minus 2 as z power minus 2 y of z, and it goes on here. So now your transfer function is given by y of z divided by x of z. So take move all your y of z one side, all your x of z another side, and take y of z commonly out and x of z commonly out. So y of z divided by x of z is nothing but b naught plus b1 z inverse. It goes on up to bm z power minus m divided by 1 plus a1 z inverse plus it goes on a suffix n z power minus n, where your m is number of zeros and n is number of poles here. Structures of IIR filters. So the most commonly used for structures are four different types. One is direct form 1, direct form 2, and parallel form. Basic symbols that we are going to use is adder, right? So here this adder, if two signals x1 and x2 are the input, the output will be a y of n, which is nothing but the addition of these two signals here. And next one is your multiplier. If x of n is going to be the input and then the constant which is to be multiplied is a, the output will be a into x of n. Then will be the delay element, right? So if x of n is passed to this delay element, is nothing but x of n minus 1. So with this basics, we can start our direct form 1. So here in direct form 1, let us consider an LTI recursive system where the difference equation just be so. So in this direct form 1, we are going to get two equations. One is y of n is equal to something, other one is w of z is equal to something. After getting these two equations, we'll be drawing the structure. So this is it, right? So first I'm going to expand this one by substituting the value of k is equal to 1 to n for y of n minus k and k equal to 0 to m for x of n minus k. After expanding this one, I'll be replacing your input present and past input terms as w of n, temporary function w of n. That is b naught x of n plus b1 x of n minus 1 till your bm x of n minus m. And then I'll be replacing this lengthy equation by this w of n. This input equation is w of n. So y of n equal to minus a1 y of n minus 1 minus a2 y of n minus 2. It goes on plus w of n. Now I got this two equation. W of n is equal to something and y of n is equal to something. Now I'll take the z transformation for this one. So y of n is nothing but y of z. So minus a1 z inverse y of z minus a2 z inverse z power minus 2 y of z, it goes on plus w of z. And I have found the z transformation of w of z. Now I got this two equation, y of z is equal to something and w of z is equal to something. So for this one, I'll be drawing the structure. So now y of z equal to minus a1 z inverse y of z. So this z inverse is from y of z. So I'll be taking the z inverse from y of z. So minus a1 into z inverse y of z and minus a2 y z power minus 2 into y of z. It goes on until minus an z power minus n into y of z. So this is equal to plus your w of z. Right? Now second equation. So w of z is equal to b naught into your x of z, then b1 into x of z, z inverse x of z, b2 into x power minus 2 into x of z, it goes on. So where you are taking your delay element, so you just see here it is z inverse x of z. So from this x of z, I'm taking the z inverse. So this is your direct form 1. So here what happens, your input and then output has the separate delays here. So how many multipliers are there? Here you have m multipliers along with this one. So here it is m plus 1 and this side it is going to be n. So m plus n plus 1 multipliers it has. And how many delay elements here you have? Here you're going to have m delay elements. Here you're going to have n delay elements here. So the direct form 1 structures have separate delays for both input and output. And m plus 1 plus 1 multiplications, m plus 1, m plus n addition, and m plus n plus 1 memory locations. Now we can solve one problem here. So realize that our second order digital filter y of n equal to zero point 0.5 y of n minus 1 minus 0.25 y of n minus 2 plus x of n plus zero point 0.4 x of n minus 1 in direct form 1. So first we are going to write the equations here, right? So in that equations, I am going to equate the input present and the past input equations as w of n, temporary function. So here x of n plus zero point 0.4, x of n minus 1. I'm going to replace this y of n equation with this one, right? So before that, I just take the z transformation. So y of w of z equal to x of z plus zero point 0.4 z inverse y of z. Here what happens after replacing this y x of n plus zero point 0.4 x of n minus 1 as w of n, I got the z transformation. So in your direct form 1, you have to get two equations. W of z is equal to something and y of z is equal to something. So I got these two equations. Now we can see how to get the structures for this. So now I'll be drawing the thing. So this is the basic thing that you have to do: x of z, w of z, and then your y of z. So this basic structures I'll be drawing. Now I'll be getting the equations here. So w of z is equal to x of z, right? So x of z. So this is going to be the first x of z plus zero point 0.4 z inverse x of z. So from your x of z, I'm just getting your z inverse, and then I'm just going for the so 1 into x of z. So 1 into x of z and zero point 0.4 into z power minus 4. This side is over. Now y of z is equal to zero point 0.5 z inverse y of z. So from your y of z, I'll be taking my z inverse because z inverse y of z. So from your y of z, I'm taking a z inverse, and then I'll be fixed. Then I have a minus 0.25 z power minus 2 y of z power 9. So z power minus 2. Now your first factor coefficient will be zero point 0.5, and for the second delay element the point is minus 0.25 and plus z of w of z is already there. So this is your direct form 1. To get two equation, that is in the main equation input and input related expression is equated to w of n, and replace your main equation by w of all your input in your main equation is w of n. So you'll get two equation: y of n is equal to something, w of n is equal to something. Take the transform and draw the structure. So this is about your direct form 1. Next, we'll see the direct form 2. So in this one, we are going to consider the same equation, and we are going to find your y of z and x of z. But here the thing is, you have to equate you have to find your y of z divided by x of z. So I'm just moving all my y of z one side on all my x of z another side. And then I'm taking my y of z commonly out here, x of z commonly out here. Then y of z divided by x of z is given by a transfer function. So I got this y of z divided by x of z. Now here what I'm going to do is this y of z divided by x of z in this function, I'm going to multiply and divide a temporary function w of z. So I can write your y of z divided by x of z as y of z divided by w of z into w of z divided by x of z. So now I'll be equating this one. So y of z divided by w of z, w of z divided by x of z into a 1 divided by 1 plus a1 z inverse plus this denominator. So this y of z divided by w of z is equal to something you get. So now I'll be getting you y of z is equal to multiply this denominator into this side. So b naught into w of z, I got it. So now I got the first equation, y of z is equal to something here. Now I have to get w of z is equal to something. So for that one, I'm just taking the next part of the equation. W of z divided by x of z as this one. Right now I cross multiply this one, I got it. So my aim is I have to get w of z is equal to something. So I keep my w of z one side, remaining things to the other side. So now I got so W of z is equal to this x of z here minus a1 z inverse W of z. So your z inverse is from W of z. So from your W of z I'll be taking so minus a1 into W of z and minus a and a2 into W of z power minus 2. So likewise I'll be drawing this side. And then the previous equation your y of z is equal to b naught into W of z b1 into W of z minus z inverse into W of z. So I'll be getting this equation. Now we'll solve one problem here. So here, before that one, the direct form 2 structure have a common delays. You just see here you have a common delays. Your delays have your input and output is going to have a common delays here. And then here you have n plus n plus 1 multiplication, but the memory locations has been reduced here. That is either which is the maximum value, whether your input or output has a maximum value. Depending upon that, you have it, right? So since the memory location has been reduced, we can call the structures as a canonic form also, right? I will solve a problem here. Realize a second order digital filter w y of n is equal to that same problem that we have solved it for direct form 1, right? So here I'm going to take this equation. I'm going to take the z transformation of this one, and I'm moving all your x of z one side, all your y of z another side, and I'm going to take your y of z outside this side and x of z outside that side of the equation. Then I'm going to find y of z divided by x of z. Here I'm going to multiply and divide by y w of z, and then I'm going to equate y of z divided by w of z to the numerator, and then I'm going to get the equation, and then I'm going to equate w of z divided by x of z equal to 1 divided by 1 minus zero point 0.5 z inverse plus 0.25 z power minus 2. So from this 2 I'll be getting the equation. From this one I'll get y of z is equal to something, and from this one I'll be getting w of z is equal to something, right? So with this one I'll be drawing the structure here. So now I'll be getting this one. So x of z, your w of z, and then y of z, whatever it may be, you have to get this common, right? So now what I'll be doing now, your y of z is equal to w of z. So 1 into z plus zero point 0.4 z inverse w of z. So where you have to take this delay from your w of z, you have to take this delay. So from your w of z, I'm just taking this delay. And what is the multiplication factor here? It's zero point 0.4. Right, so that's it. I have completed the first equation. Now I'll be taking the second equation. So w of z is equal to x of z. So already it is in x of z plus zero point 0.5 z inverse w of z. So from your w of z, again you have to take your uh, delay element. So what is that one? Next is your 1 into x of z plus zero point 0.5 z inverse w of z and minus 0.25 z power minus 2 w of z. So from your w of z, I'm going to take another delay element, and your multiplication factor is minus 0.25. Right, so this is your direct form 2 structure, a common delay for your input and output here. Right, so this is about your direct form 2. So this is how you have to solve the problem if you are going to ask uh, you the structure of your direct form. For your cascade and parallel, same thing you have to do, but you have to break your h of z into pieces here, and for each and every chunks you have to get your direct form 2. So in such case, you can draw the direct form 2 directly from your h of z. So now I'll tell you how to draw the direct form 2 directly from your h of z, which will be helpful for your cascade and parallel. So for cascade and parallel alone, you have to draw the direct form 2 directly from your h of z. But if they ask you to draw your h of z, direct form 2, have to derive the steps as previously, and then you have to derive. So now for this problem, you have to take your y of n and find your take your z transformation and find your h of z. So after finding your h of z, you have to get your numerator and the denominator. So you just check which one is going to have the maximum delay. So here numerator as well as denominator has two delays. So your common thing will have two delays here, right? So your x of z, w of z, and y of z. So always your numerator will have your this side, right hand side, and denominator will be in the left hand side, right? So in the numerator, zero point 0.7, that's going to be the first one, constant value, and z power minus 2 is 0 here, so I left open here, and your z power minus 2, your coefficient value is minus 0.252. So this is the way you have to fill your right side. Your numerator belongs to the right side. Now we'll go for the left side here. Always your x of z coefficient will be 1 in your IIR filter. Next, the thing here you have to note down is the denominator belongs to this left side, and here the coefficient of your delay element should be the sign of your coefficient should be reversed. Here it is plus zero point 0.1, it should be written as minus zero point 0.1. Here it is minus 0.72, here it should be plus 0.72. So in the numerator, there won't be any sign change, only for the denominator, you'll have your sign change. So you'll get used to it while you're doing your problems here, right? So now we'll see the cascade form. Here the cascade form, the h of z will be expressed as a product of number of either first order or second order. So we have to opt for first order first. Then each and every sections will be separately realized in your direct form too. So this way, h of z is divided into chunks as h1 of z, h2 of z as hk of z. Each and every transfer function will be of minimum of first order, right? And then we'll be drawing this direct form to structure and placing it next to each other so that you'll be getting your cascade. Now we'll see a problem here. Realize a system with a difference equation and a cascade form, right? So now you just take your y of n, find your h of z first of all. So for finding your h of z, take your z transformation. So y of z equal to 3 by 4 z inverse y of z minus 1 by 8 z power minus 2 into y of z plus x of z plus 1 by 3 x of z inverse x of z. So take all your y of z one side, all your x of z another side, and then your h of z will be given as this one. So here after getting your h of z, so numerator is in first order, no problem. Denominator is second order. So try to factorize this one. You just check whether you are able to. Right, so I can factorize this one as 1 minus 1 by 2 z inverse and 1 minus 1 by 2 z power minus 1. So now I can have it into two functions. So here denominator has two functions. So I can have your h1 of z and h2 of z. So 1 plus 1 by 3 z inverse divided by 1 minus 1 by 4 z power minus 1 into 1 divided by 1 minus 1 by 2 z inverse. If your numerator get exchanged also, nothing wrong. It's going to be changed. Okay, it's going to be a correct one, right? And I hope you know how to factorize it using your calculator too. Either manually you can factorize or using your calculator you can factorize. So just go to your mode and go to the in the mode you have your equation EQU option. After pressing twice the button of mode, you have your EQU option. In that one, you just press your right arrow, you'll get your degree. Right? If you choose your 2, you'll get your A equal to. So just press your 1, and for if you press enter, you'll get your B watt symbol. So press your minus 3 by 4, and if you press equal, you'll get your C. Now you press your 1 by 8. After pressing it out, you will get your x1 equal to 1 by 4 and x2 equal to 1 by 2. So from this, I'll be getting it out 1 minus 1 by 4 z inverse and 1 minus 1 by 2 z power minus 2. Now draw the direct form 2 for this H1 and H2. So how to draw the direct form 1 for the H1? So here I'll be taking this one. Numerator and denominator has only one element here, delay element. So I'll be taking your one delay element. So numerator belongs to this side. So it's going to have plus 1 and plus 1 and 1 by 3. Your z inverse coefficient is 1 by 3. So I took your 1 by 3. The denominator, it is minus 1 by 4. It will becomes plus 1 by 4. And similarly, I have to draw the direct form to structure of H2 of 1, H2 of Z, which should be placed adjacent, right? So here I'll be taking this same thing, and then here numerator there is no delay element, but denominator is having one delay. So I'll be getting this delay. So numerator only the constant value, so I'll be getting your 1, right? Denominator it's minus 1 by 2. I have to get a change, sign change, and then it becomes 1 by 2. So this is your cascade form. So H1 of Z direct form 2, H2 of Z direct form 2, and it is present in the cascade manner, right? So next we'll see the parallel form. So parallel form is similar. You have to break your using your partial fraction method, break your transfer function into C plus it's a sum term, right? After placing it as sum term, you have to find the direct form two of each of these chunks and then have to place parallelly, right? So we'll solve a problem here. So realize the second order filter in a parallel form, right? So first you have to take your y of z, find your h of z, take your z transformation, move all your y of z one side, all your h of z another side, and get your h of z. Now I have to use your partial fraction method to make it into a sum term here, right? So to do your partial fraction method, first condition is your h of z should be in positive powers. Here it is in negative powers, so I'm changing it into positive powers. I'm taking your z power minus 2 commonly out so that the numerator becomes positive. The maximum of your denominator also z power minus 2. I'm just taking it out so that this just z power minus 2, z power minus 2 get cancelled. So I'll be getting my h of z into positive powers. Now I'll be start applying my partial fraction method. The first term in your partial fraction method is you just factor your denominator, right? So I'll be factorizing my denominator. Second step, step number 2 is divide by z on both sides, right? So h of z divided by z and this numerator divided by z into z plus 0.9 into z minus 0.8. Now I have to introduce the constants, sum of your constants here, right? How many terms here in the denominator? That many number of constants I have to use. So here three terms constants, 8 by z plus b by z plus 9 and c divided by z minus 8. So here first step is factorize your denominator, second step divide by z on both sides, third step write it into a sum. How to find your constant value? A is equal to the denominator of a into h of z divided by z, for z is equal to 0, the poles of your z. So z into h of z divided by z value and then z is equal to 0. Before substituting your z equal to 0, cancel this z and z and then for the remaining function, substitute your z is equal to 0. So zero point 0.7 into 0 minus 0.252 divided by 0 plus zero point 0.9 into 0 minus 0.8. So the value will be 0.35. Similarly, I'll be finding my b values too. So denominator z plus zero point 0.9 into h of z divided by z, where z is equal to minus zero point 0.9. So the pole of that one. So cancel this z plus zero point 0.9, z plus zero point 0.9. For the remaining value, just substitute your z as minus zero point 0.9. So your value of your b will be 0.206. Similarly, I'll be finding my c. So now I got your h of z divided by z as 0.35 by z, 0.206 divided by z plus zero point 0.9 and 0.144 divided by z minus zero point 0.8. Here, have to get your h of z back into some terms where each and every term will be in the negative power. So, multiply by z throughout. If I multiply by z throughout, this z get cancels, this z get cancels, and here what happens? I have to cut it into negative power. So, take your z out. So 1 plus zero point 0.9 z inverse. So this positive z and z get cancels. Similarly, here also I'll be getting. So now I got my h of z into a sum term, negative powers. Now for each and every term, I have to get my direct form too, and I have to place it parallelly. So first I'll be getting the direct form 2 of this one, right? H1 of z. So here your input, your numerator will be this side, your denominator will be this side. So numerator 0.206, denominator is minus zero point 0.9, right? Then I'll be getting my direct form 2 of your H2 of z. So numerator this side and denominator is this side. So minus zero point 0.8 becomes plus zero point 0.8. Now left out is 0.35. So the constant 0.35. After placing it all the three terms parallelly, just join your input and join your output. That's it. Now commonly I'll be giving one input for the structure x of z. I'm going to take one output here y of z. So this is your parallel form. So parallelly I have placed the direct form 2 of your each and every things here. So thank you guys. We can meet in the one more another presentation. If you have any doubt, you just ping me at benila.blogspot.com. Thank you.